blah, blah, blah. Hello students, this is video 3.11. This is rooftop triangles unit. The objective is students will be able to use sine, cosine, tangent ratios to determine missing sides and angles. And your IXL skills are R1 and R9. Okay, so you may want to try those. Alright, let's go flippers. So the most recent lesson we worked with was Pythagorean theorem, and we were looking at right triangles. So we're going to stay working with right triangles, and something that actually works with right triangles are called trigonometric ratios. That's right, guys, we are doing trig. So trigonometric ratios are equivalent ratios, ratio, A over B, 2 over 3, those are ratios, okay, that exist in similar triangles. So if we have trig ratios, we can use them to find the measure of side lengths and angles of triangles. So I'm going to draw a right triangle here, and we'll be able to find these lengths here. So I'm going to highlight those side lengths and then the angles inside. So we'll be able to find all the measures of the angles. And of course here we know this angle, that would be a right angle. There are 3 specific trig ratios we'll be working with, and they are called sine, cosine, and tangent. So we're actually going to pick an angle, angle A, and we're going to actually write the trig ratios for angle A. So here we go. So the first one we want to do is sine. And sine is going to be opposite over hypotenuse. So we go to angle A, and we're looking for the side opposite. So if I'm at this angle, I'm going to make sure that I am going opposite the angle. So if you can see, it's almost like I'm drawing an arrow across. That is the side opposite, and then over the hypotenuse, which would be A. So the ratio we'd write would be A over C. Cosine is a little different. Cosine is the leg or side adjacent, okay, to, and then over the hypotenuse. So then, again, we're going to go to angle A. And we're looking for the leg that is adjacent. So here I am, and the leg adjacent is not just right there. It's actually touching angle A. So that would be B, and then again over the hypotenuse. So we're going to write B over C. And there's the last one, which is really kind of cool. Tangent is actually made of both legs, and it's going to be opposite over adjacent. So again, I'm going back to A, and I'm looking for the opposite, side opposite, that would be A, over the adjacent, which is B. So that would be A over B. And there we have it, okay? We could have done this for angle B, and we could have done this for angle C. And these terms would be different because, again, the side adjacent to angle B would be actually A. The side opposite angle B would be side B. And again, we're going to look at a problem now to see how this would actually play out. If we look at this triangle here, triangle MKL, and we ask you to give us the, let's say, for angle L, all right, find the sine of angle L, we're going to find the cosine of angle L, and we're going to find the tangent of angle L. And again, when you start problems like this, you want to make sure that you figure out, hey, where's the hypotenuse and where are the legs? So here's our right angle, so we know these are our legs. This must be the hypotenuse in for all the problems, for every problem, no matter which angle you start from, that is the hypotenuse. So let's do the sine of angle L. Okay, so the sine of angle L here is going to be, if we go to angle L, and we look for the side opposite, that would be 7, and then over the hypotenuse, so that's going to be 7 over 9. Cosine, again, I'm looking for the side adjacent, and that would be 4 radical 2. And then again over the hypotenuse, which is 9. And we can't reduce that because they don't have any common factors between 4 and 9. And then last, the tangent of angle L, I'm going to actually use the side opposite over the adjacent, which is 4 radical 2. A couple of examples. Number 1 says, what are the sine, cosine, tangent ratios for angle T? On angle T, and here it is, let's find all 3. Sine of angle T here is going to be opposite over the hypotenuse, which is going to give me 8 over 17. I can't reduce that, so I'll just keep going. The cosine of angle T is going to be this, which is adjacent over the hypotenuse, which is 15 over 17. And then the last one, tangent, is going to be the opposite over the adjacent, which is 8 over 15. There we have it, folks. Let's look at number 2. Number 2 says, what is the measure of angle x to the nearest degree? Ooh, so now we're looking for a measure. What we're going to do is we're going to find the angle in the picture they're talking about, which is angle x, and we're actually writing that angle down. Use the lengths of the hypotenuse here and of the side opposite angle x, which is 6. And if we use those, we'll actually have sine. Remember, sine is opposite over hypotenuse. So if we write that, we'd have 6 over 10. Okay, and that came straight from the picture. I found angle x. This is side opposite is 6, and this is 10. And remember, we're looking for an angle measure. So which trig ratio we're going to use? A sine we're going to use. I recognize it, but this is basically an algebra problem. But in order to sign this, we have to use something in the calculator called the inverse trig function. And it's going to look like this in the calculator. It's going to look like sine -1. So that button. So let's actually write this out. The actual measure of angle x is going to be equal to the inverse sine, and that's what we call it, inverse sine of this ratio, 6 over 10. Again, inverse sine. So in our calculator, we would actually push the sine -1 button. Then we'd actually press 6. And we'd actually divide it by 10. We're going to make sure our calculator is in degree mode, and then we'd press enter. And you would get approximately 36.8698965, but you could just round that to 37 degrees. Again, this was us finding an angle measure. And this is an IXL skill you have to do. So make sure you review that question. And you can do this online. So if you go to Google, you can find a graphing calculator where you can actually use this, so you don't have to have your graphing calculator from class. It actually works on your iPhone too, I believe. So our last question is to find x. So in this particular picture, we are trying to find what this side is, x. And we are given an angle, which is 39 degrees. We are given a side length, which is x and 15, and we don't know what this is. So when I look at this picture and I look at that angle, I'm going to write the angle measure down because it's 39 degrees. And it's in this corner here. It's in this particular corner. And when I look across from it, I see that there's a measurement, which is x. And then when I look next to it, I see it's 15. So if I were to try and figure out, given this angle, which trig ratio would be more applicable? It appears that I have a side opposite this angle, and I have a side adjacent. I don't know how the hypotenuse, so I really can't use any of the trig ratios to deal with hypotenuse, but I can use one that deals with this, which is the side opposite, and this, which is side adjacent. You guessed it, it's the tangent. So this means that the tangent of 39 is equal to x over 15. Hey, it looks like an algebra problem, and it actually is. How do we go about solving this now? Well, we do what we normally do. We want to get x all by itself. Multiply both sides by 15. I'm going to put this part in parentheses, and here you use a graphing calculator again. You'd actually type in 15 times the tangent of 39, and you'd hit enter, and you'd get roughly about 54.21. Again, which would clearly be the length of that side, x, what we're looking for. Flippers, here is your secret hot question. It says, what is the measurement of angle x to the nearest degree? Here, this side is 12 HB, and this side is 20. You're looking for the measurement of x. So try and figure out which trig ratio you need to use, and you will probably need to use one of those inverse trig calculator functions. All right, so here we go. Make sure you do your IXL skills. Later, dude.